Jürgen Schmidhuber. So Jürgen Schmidhuber claims to have invented principles of meta learning, the generative adversarial network, transformers, back in 1991, and in that same year also very deep learning. According to Elon Musk, Schmidhuber invented everything you've ever heard of. And now Jürgen Schmidhuber, it seems like he's saying he invented Q star, and he's got an image to prove it. Don't take this thing 100% seriously. And we're going to cover it at the end in case you're interested. But there's much bigger things that are happening right now. And here's one. So here's Demis Hassabis, maybe arguably the number one person pushing AI forward outside of OpenAI. So here's Google DeepMind, their sort of blog. Millions of new materials discovered with deep learning. This to me is so strange conceptually to think about. So the AI, the neural network, is kind of like a brain. Its structure is, you could say, similar to the neural structure of the human brain. But instead of being made out of fat and protein and placed in our heads, it's digital. And they get trained, so they become useful when we feed it tons of data. We feed it tons of texts, and it becomes something like ChatGPT, where it's able to answer questions and maybe even do certain reasoning tasks. If we take a neural network and we show it a bunch of images, interestingly, it starts creating excellent images. There's even some research showing that it kind of builds these mental models potentially about how to create those images. It almost has like a 3D representation of the world, even though it's trained entirely on 2D images. It starts figuring out like, hey, this object is closer to me. This object is further from me, etc. This is why it's so exciting, is it seems to be like this sort of technology we uncovered. It goes much deeper than we would have thought 5-10 years ago. And so Google DeepMind in 2020, so not that long ago, figures out how to guess at the 3D structure of proteins. So proteins is basically these little life factories that make everything go around. Any function that you think of as life probably is on one level or another controlled by proteins. They're made up of amino acids, and those are pretty easy for us to sort of read, right? Kind of like a letters in a sentence, we can kind of see what those are. But then those things fold into a 3D shape, and that shape is insanely complicated. The number of different unique 3D positions that shape can be, there's more of those possibilities than there are atoms in the observable universe. So it's kind of a big number, right? Can we say that? It's not even astronomical. It's like beyond that. But slowly through time, we were able to figure out the structure of these proteins. So we collected a number of them that we slowly, tediously, painstakingly figured out. And so we have like a database of them. We train AlphaFold on that database. AlphaFold begins correctly guessing at the 3D shape of the protein. It even is able to discover new proteins whose shape we did not know before, which again, to me is kind of strange. Like if you think about it too deeply, because it's not guessing. It's not like it's going through all the possible variations and it just keeps guessing until it gets the right one. It looks at how all the other ones are shaped, and then it figures out what this one is going to look like, the one that we haven't seen before. But the point is that if you think about, so we as humans, we generate certain data. We generate textbooks and images, and then we feed it into the AI, and it gets really good at whatever that thing is, at producing images or producing text. We feed it protein data, and it gets good at guessing more protein data that we can't even understand how it's doing that. So the kind of next big obvious question is, okay, what else does that apply to? What other things, what other data can we feed it to where it's going to come up with these insane solutions that we can't even begin to approach? And so I think a lot of people were waiting for this next shoe to drop. And well, I think today is the day, or yesterday rather, 29th of November, because the same AI, the foundation between a lot of these models from what we've seen from DeepMind, they're saying a lot of them are the same. So the AI that plays StarCraft, the AI that plays chess, the AI that plays Go, the AI that optimizes machine code to make it faster, all those breakthroughs are out of DeepMind. Like they're separate sort of AIs, but the way that DeepMind is building them, they're similar. And so this is yet another. AI tool GNoME finds 2.2 million new crystals, including 380,000 stable materials that could power future technologies. And so they're introducing graph networks for material exploration, GNoME or GNoME, our new learning tool that dramatically increases the speed and efficiency of discovery by predicting the stability of new materials. With GNoME, we've multiplied the number of technologically viable materials known to humanity, meaning that this thing is able to sort of predict on paper, right, theoretically, these materials that are stable, meaning they can be used to build stuff with. Which means if we're able to synthesize it, if we're able to make it in a lab, we can potentially use those materials. We know what their sort of characteristics are going to be, so we could potentially use them to replace materials that we've been using for a long time, because these newfound materials are going to be potentially much, much better. So they have the potential to develop future transformative technologies, ranging from superconductors powering supercomputers and next generation batteries to boost the efficiency of electric vehicles. So it looks like external researchers in labs around the world have independently created 736 of these new structures experimentally in concurrent work. And they've published a paper in Nature, which is this one right here. And they're referring to it as an autonomous materials discovery platform. And similar to AlphaFold, they're also sort of creating a database where people can go, where researchers can go and see those new materials and use them for their own research and stuff like that. And this is the picture that to me kind of really, I think, kind of sheds light on this concept that is so kind of mind-blowing, I think. So this deep blue circle, that's human experimentation. So that's all the stuff that we've been able to find using our best thinking, our best brains, our best equipment, right? And then that's 20,000, right? And then with computational methods, we were able to find this sort of secondary circle, 48,000, so more than double the amount that humans alone could find. And then comes this AI, because keep in mind, this AI, a lot of these ideas like neural nets, they've been around for a long time, but there hasn't been too much progress until very, very recently. And then when that progress came, it kind of exploded. It hit that inflection point quickly. And it seems like it's still, I mean, it's pretty obviously still rapidly accelerating. So GNoME found 421,000. GNoME expands the number of stable materials known to humanity to 421,000. And so when people say that AI could be the greatest scientific discovery that humanity ever achieves, I think this helps understand why. Because what we're seeing is this next sort of evolution of AI, it almost teaches itself. It learns from itself. And it's beginning to make scientific progress so much faster than humans could. So if we keep on creating this AI that eventually starts improving itself and learning more and more about science, I mean, one perspective is that it will be pushing scientific progress forward much faster than humans alone. So we might have invented AI that will then invent everything else. And not only is the scale of this kind of staggering, but you also have to consider sort of the recursive nature of this, the compounding. So here they say, for example, 52,000 new layered compounds similar to graphene that have the potential to revolutionize electronics with the development of superconductors. So the question becomes, okay, so once this AI discovers all these compounds and we figure out how to synthesize it, probably with the help of AI, and then we use those sort of improved compounds to create better computers, better batteries, better microchips. That in turn will drive better AI. The data it produces will help it predict and get better at producing more stuff. The breakthroughs here will help us discover other avenues where we can use this. So for example, once AlphaFold proved that we were able to guess accurately at the 3D structures of the proteins, like this is an amazing discovery, but we kind of almost like expected more stuff like this. There's genetic companies that are doing something similar with the human genome, for example. Can we take this massive amounts of data about the human genome, about our DNA, can we feed it into an AI and have some sort of insight, some sort of solutions, maybe cures to certain diseases from that AI? So at this point, I think it's kind of safe to expect more and more of things like this rolling out. So this is kind of a low graph of how that neural network works. You have the structural pipeline, the compositional pipeline, and this repeats for rounds of active learning, and it comes up with these AI recipes. So here's some things that we think might work. The AI predicts that this might be useful, might be stable. And then this robot goes to work. And so here's that paper in nature.com. So they're saying that the synthesis and characterization is done by a robot. And so there's that central robot arm made by Mitsubishi. It's sitting there with powder dispensing and mixing and a heating station with 4 box furnaces and 2 collaborative robot arms that help kind of transfer samples and stuff. And then they have their material screening. So they're just making sure they don't make something that blows up, right? So there's certain things that they're not touching that potentially could be dangerous, but so here's what that thing kind of looks like. So I'm assuming it sounds like they have it like behind glass. It's its own little room, just in case, maybe a few compounds don't mix properly and there's a big boom that happens. But yeah, I mean, this is what's happening now. We have research done by digital brains being carried out by robotic arms. But that's nice. But is it working? Is it real? Well, in 17 days of closed loop operation, the A-Lab, that's that little robotic arm that moves around in its low cage, performed 355 experiments and successfully realized 41 of 58 novel inorganic crystalline solids with diverse structures and chemistries. The unexpectedly high success rate, 71%. By the way, it sounds like here they're using machine learning and active learning algorithms. So they're using AI on that back end too to improve the synthesis. So it's AI all the way down. And so they're saying it seems like it's pretty easy. They're going to bump up the success rate to 74 with just a few easy, simple tweaks, and that autonomous research agents can markedly accelerate the pace of materials research. This rapid discovery points to a vast landscape of opportunities. For me, as someone who's been in e-commerce since 2011 and have spent quite a bit of money on Google Ads, I'd like to think of myself as someone who helped fund some of these experiments that are leading now to a greater future. You're welcome. I'm kidding, of course. I didn't really have anything to do with it. In other lighter news, here's how the next generation of humans, here's how they will code. Take a look. Imagine you wanted to create a little timer. And so you drew out how you want it to look, what the different buttons do, right? Reset, stop, plus minutes per seconds, and you're done. Here's that out. It took about 5 seconds. But let's say the computer got it wrong, so it should be counting down or whatever. So you make a note and boom, it fixed it. You debugged it by writing, that's wrong, fix it. And it's fixed. Here's creating a game where you jump over little obstacles and you get a +1 score every time you manage to successfully jump over it. You draw it out, make some notes, click make real. And so that took about 15 seconds or so. And there you go. So you're jumping over obstacles, and each time you manage to jump over it, you get +1 to the score. So it looks like the life system doesn't work, but that's an easy fix. Here, you put a photo of the celebrity here. And then it's like Hangman, so where you guess the celebrity, right? So you can see, so they add a visual keyboard, modify the screen. So they're adding one at a time, sort of just adding different versions and building it up until it's finally complete and it looks the way that you want it to look. And here's the final version of that. So you're trying to guess who that is. This person is guessing Jay-Z, or I guess that was correct. I'm going to guess Tom Hanks. Correct. You're able to create an invoice generator. So just sort of write out what you want on that page. And within seconds, it gives you this create invoice sort of form. You put in kind of what the invoice is and it will generate it for you. By the way, this generates HTML. So you're able to take that code and go put it somewhere where it's going to run. You can do it as an app on your desktop. You can put it on your website, whatever. So if you wanted to try it for yourself, so if you know what TLDR is, like too long to read, so meaning like a summary. So this is tlddraw.com. So when you go to tlddraw.com, this by itself is a pretty good sort of diagramming tool where you can draw. And it's I got to say, it's got really good drawing abilities. Just by default, kind of makes everything look kind of good, which is very cool. So you're able to draw, you're able to do little text box like this and point the arrows to it, right? You want like a red arrow over here and add some text. I got to say, just this alone is very well made for creating little diagrams or sketches or whatever. But the real magic is you have to know the secret URL link. I'll leave the link in the description. And so it does require your API key. So you head over to platform.openai.com/API-keys. All right, then you add your API key in there. And so let's say I wanted to create a little timer just to start off with something simple. And so I'll make a little box like this and I'll point here, and that's where the timer goes. Here, start at 00, default, show minutes, seconds, and let's say you forget what comes after. You can say the next unit of time, and then we'll say timer counts down. And then we'll have two buttons. This button will be start. I need brighter colors here. How about this? Red. And this will be reset. Actually, this will be pause, and we'll change to reset when pause. And we'll also need like a +1 minute button. Let's put that right here. Add 1 minute to timer. All right, then we select all of this and we're going to hit make real. And so this little box pops up and it starts generating the thing that we so masterfully drawn. All right, there it is. So I like the fact that honestly, so it didn't do pause. It didn't do the pause button. The layout is a little bit different, but I feel like it's because I kind of like screwed up the layout, because I've seen other people, when they do a layout that makes sense, it shows up exactly correctly. So add 1 minute, start, and it starts counting down. So that's pretty good. I think the problem was more how I set it up, not anything wrong that it did. So let me do this. So timer starts at 0000. User can add time. Timer counts down in minutes, seconds, and milliseconds. This will be add 1 minute to timer. This will be add 10 seconds to timer. This will be start timer, and this will be reset timer. All right, let's try that. I think that's going to work better. All right, so there it is. I think that took about 20 seconds or so. So let's add 1 minute. So the buttons here don't work. Let me see what the issue is. I think the timer units are throwing it off the milliseconds. So add 1 minute. So double click on it to interact. Add 1 minute. Perfect. Add 10 seconds. Perfect. Start timer. And it starts. Yeah, everything's perfect. So add 2 minutes and 30 seconds. Start timer. Boom. Yeah, the milliseconds were throwing it off, but whatever. All right, final thing. Let's do a video game. Let's do a quick game. So here we're going to have the player. that blob is the player. And these things here are the chickens. And then we'll make some notes here about the game. So the chickens move in a random direction. When they hit a wall, they bounce in a different random direction. The player moves towards the mouse cursor. When the player gets close to the chicken, make the chicken disappear and add +1 to the score. And we'll put the score here. Score goes here, starts at 0. All right, so let's select this whole thing. So when you click make real, whatever you select is what gets passed. So as you can see here, I can have tons of different stuff going on, but whatever I select is the only thing that gets created in its own special area here. All right, so that took, I want to say, I don't know, 20 seconds or so. All right, so double click to interact. Well, okay, so that is cool, but not quite what I had in mind, because the player, so I wanted the player to kind of slowly move in a direction, not move as fast as the mouse. So the player moves closer to the location every frame. So let's try that, if that makes a little bit more sense. All right, so that fixed the cursor. This is more kind of like what I had in mind, but where are the chickens? And why is my score so high? Start with 5 chickens located randomly. Start with 5 chickens located randomly on screen. All right, there we go. I'll make that larger and let us begin. Well, it's still having some hard time understanding what this player is supposed to be doing. So let's spell it out. So this is the player and this is the mouse. So every frame, make the player move closer to the mouse, and that's the mouse. All right. So another 20, 30 seconds, and there we go. Okay, that's exactly what I had in mind. So we sort of drag the thing in the direction that we want to go, and we can eat all of the chickens. This chicken got stuck in a corner, I guess. Okay. So that's very good. And we just need the final touch. Start the game with an intro screen that has a start button. Once the player hits the start button, the game starts. And then we need some sort of a background for the intro screen. So let's use this. So use that as the background for the intro screen. All right, there it is. So that took a little bit longer, maybe 35 seconds. I'm going to have to eat every chicken in this room. That is terrific. Start the game. So double click to interact, start the game. And yes, that is precisely more or less what we wanted. This game will be available for purchase in the description of this video. Just kidding, it's not. But here's the thing. By the time you're watching this Tldraw has already evolved to its next shape, to its next form. Check this out. So first of all, they sped it up. It's now much faster. It looks like they're making it easier to create certain diagrams, certain sketches. You're able to create certain physics and bouncy shapes, slippery materials, and rotating boxes. So this is basically, you can recreate Angry Birds. This is Angry Birds. And also they're adding something that I'm not even sure what to call it. It's as you drag certain images or you create certain images within, let's say a square, it interprets it into something that you said it should do as you're drawing it. So I'll show you a different one. It'll probably make a little bit more sense. So take a look at this. So we take this picture of a tomato and we change it into tasty, delicious candy, disgusting, horrible vegetables, like it's kind of rotten, futuristic robot car. Yeah, I don't even know what to call that. It's like viewing some object from different lenses, from different perspectives, maybe. You're able to, for example, draw a letter and have it be sort of recreated in whatever form you want. So for example, from carved wood. If you ever wanted to create your own font, I feel like this would make it very easy. Here's like a little diagram of stuff falling to the floor. Wow. Oh, didn't expect that. Dominoes. Here's a shot of it sort of organizing a diagram into just a better layout, from messy to just more visually appealing, easier to read. So I got to say, it's incredible how easy it is to make your idea come into life, how intuitive it is, the speed with which you can build this stuff. And I apologize, I forgot to show you one last thing. So here's our little game that we just created. So we can copy the URL to the clipboard, open it, and send it to somebody else to play. Or we can copy the HTML to our clipboard, post the HTML into Notepad, and save that as, let's say, chicks.html, save that as all files, save. And so there's that, and you can run it locally in your computer. So it's absolutely incredible to think where all this is going. I feel like development is going to get so much easier, because if you think about what code is just whatever is between what the user wants and the final output. It's just the stuff that translates sort of our thoughts, what we want, into the computer doing that. But with AI, more and more, I think it's going to get just a lot more intuitive. So it's not going to be like if you want to create something, you have to code and this is how you code. It's going to be more like, how do you want to make this? Do you want to make it by sketching? Do you want to make it by just talking into a microphone? Maybe some sort of a back and forth conversation with AI? Do you want to do it through text? Do you want to point to something that someone else has done and say, hey, just kind of start there and let me iterate on top of it? Like start with Angry Birds, but then I want to add my own twist on it. Microsoft just came out with something they call Task Weaver, where now it seems like, I haven't read the full paper yet, but it seems like what they're trying to do is to have the AI kind of troubleshoot everything. programming to take whatever code they produce for you and then go run it to figure out what worked, what didn't, and then kind of self-reflect on it before giving you the final answer. So in that situation where we're building a little chicken game or whatever, like it could probably take a look at it and say, hey, this is not quite what I think we wanted. Let me try that a different way, right? Maybe there's like a second AI that kind of like critiques it and maybe tries to make it better. Now you're still going to need to have the high level engineers and software developers for like a lot of like the advanced stuff. But if you wanted to create an app or a simple game, we're getting to the point where, I mean, any child is going to be able to do it very quickly. And finally, that brings us to Jürgen Schmidhuber. So I'm going to be honest, I don't know too much about what's happening here. There's sort of a dialogue happening here that I'm a little bit out of the loop, because it seems like he kind of comes in and maybe a little bit aggressively accuses a lot of the prominent researchers such as Hinton, Jan LeCun, etc., of maybe citing each other and kind of like giving credit to each other. But he's saying, but wait, I've discovered everything before you guys. And, Elon Musk comes in and says, Schmidhuber invented everything. And more you hear this idea of Schmidhuber invented everything. And as I'm kind of understanding it, what's happening is that everyone is saying the same thing he's saying, but everyone else is saying it ironically, like they're kind of making it a joke. And he's the only one who's like, no, for real, you guys, I invented everything. And certainly it seems like he's got a lot of clout. So here he is in 2010 with Jensen from NVIDIA. Here he is, if you ask the Llama 2 model, which Llama 2 was developed by Facebook, and Jan LeCun, who is one of the researchers that Jürgen kind of maybe talks about as maybe not giving him enough credit, So if you ask Llama about Schmidhuber, Jürgen Schmidhuber, Llama's like, oh, that's not a very good person. I don't want to talk about him. So somebody chimes in, like, it looks like an answer that was hard-coded by Jan LeCun. So I don't know what to make of this thing here. I've joked in the past that these people, as AI gets better at writing lyrics and music and stuff like that, they should create their own like diss tracks like the rappers used to do back in the days, right? So Jürgen comes in and does a diss track by Jan LeCun, and then Jan LeCun fires back. They sort of have ChatGPT write out the lyrics with the main points, lay down a fat beat, and then just release it for the rest of us to enjoy. It's just a thought. Obviously, I'd prefer all our AI researchers kind of got along and played nice together, but a part of me kind of wants to see that. And just as I'm saying that, it dawns on me, wasn't there a YouTube channel that used to do that? Yes, there was. Epic Rap Battles of History. So these guys posed as various different historical figures that would kind of like rap battle each other. They have Elon Musk and Mark Zuckerberg. I know they have Bill Gates and Steve Jobs here somewhere. There it is, Steve Jobs and Bill Gates. So maybe we're not too far off from something like that happening. We'll see. Anyways, I hope you enjoyed that. Make sure you're subscribed. We have a lot more stuff coming out. It's going to be amazing. AI is really heating up. Used to be I could do one video about one subject. And as long as I did that a few times a week, we would cover sort of the most important subjects. Now it's getting collapsed to the point where I have to do multiple huge stories in one video just to kind of at least have a chance of being able to cover them and talk about them. And I think that's what the singularity was supposed to be, is when we get to a point where the progress is happening so fast that it's impossible to keep up. And so, maybe the singularity is here is just not evenly distributed. By the way, if you're curious about who won in the battle between Steve Jobs and Bill Gates, Linux comes in and just kills them all. I thought you knew. And with that, that's it for me. My name is Wes Roth, and thank you for watching. By the way, this was like 11 years ago. This video was like 11 years ago.